Hello, good evening. Let me wash my face real quick, okay? I'll be right back. Ah, wow, happy Wednesday. Happy Wednesday evening, and yeah, it's right now. It's like 8 o'clock p.m. and I just got back home because it was busy day, and of course it was long and busy day, so I didn't have a chance to write physics today. That's fine. Well, usually day like this, it happens like once a quarter, okay? So long and busy day. So then I just come here. I don't do anything extra for the day. So yeah, I didn't write physics because I kind of need to step back and think about it. The general relativity disproof. Yeah. So let's brainstorm about that, right? But for now, let's just relax. I just got back home, so. Oh boy, it was long and busy day. 8 p.m. I got home. Oh boy. What time did I start working today? 8 a.m. Okay, so it's not that common that we have this kind of days, but today was one of those days, and but it's over now. So for today, yeah, it was good. Whew. So how was your day? I hope you had a good one. My day was good. It was busy and long. Yeah. Of course, when I was at work, I was really stressed out, but I took breaks, So, hmm? Yeah, got things done in time, basically. Yeah. Do you know what really helps? What really helped me when I had a very busy day? Yeah, social websites, uh, social media, chatting with my friends during my cigarette break. That really helps, and looking at their posts. And also another thing that really helps me is when I go to bathroom, I take selfies. That helps a lot. Why? So, sometimes I get some ego boost. I mean, I don't look always good. Look at me, right? But depending on the lighting, I look decent. Okay, so yeah, I kind of feel good when the selfie comes out right, right? Bathroom selfie, that really helps. Give me that little extra energy to me. Okay, yeah, yeah, and yeah. Anyway, so I mean, also during my breaks, I thought about the gravitation. I mean, general relativity disproof, and we got a little bit of work before I start. We start writing. Okay, just a little bit. So force 1 Newton is defined as F equal ma, Newton's law. Okay, 1 Newton of force is defined as the kind of force that's necessary for 1 kilogram of object to have 1 meter per second squared acceleration. I looked it up. Okay, so that's the definition of 1 Newton force. Okay, all right. In other words, so F equal ma, is equal to F over m, right? So to have for 1 kilogram of object to have 1 meter per second squared acceleration, the amount of force that you need is 1 Newton. Okay? Alright. So, let's say gravitational field, okay? Acceleration is 9.8 meter per second squared. We call it g, right? So then how much Newton is that? 1 times 9.8. 9.8 Newton, okay? So 1 kilogram object, if it's applied gravitational force by 9.8 Newton, then this object will have 1 meter per second squared acceleration. Yeah, the free falling object, you drop something, right? Yeah. I mean, gravitational force, it depends on the distance between this object and the center of the earth, so it changes every single point. When it falls down, it actually acceleration actually increases because the gravitational force increases as two objects get closer and closer. Okay, but it's a good approximation that gravitational force is constant. Why? Because Earth radius is very big. Okay, so this falling, like say we are falling an object, dropping an object like 10 meters from above the ground. That small distance change is nothing compared to the radius of the Earth, which is very big. Okay? Right. Now, let's say this 1 kilogram object is positively charged electrically. Okay? And in this force field, we adjust this electric force field, constant force field, such that the electric force this positively charged object feels is 9.8 Newton. Right? Then it will have 9.8 meter per second acceleration. Okay. Same goes for magnetic field. You have some kind of magnetic charge, whatever, right? Magnet, whatever. Okay, tunnel, and you have this magnet, north and south pole, right? And you apply a magnetic field so that it moves like that way. Okay, frictionless tunnel. Okay, and the magnetic force, say we adjust the magnetic force such that it's exactly 9.8 Newton, and magnetic field force, okay, and also this object is 1 kilogram, okay, and then this object will have 9.8 meter per second squared acceleration. Yeah. Wind force, same way. We have one object that 1 kilogram is mass, okay, and then you adjust this wind fan such that this 1 kilogram object would feel 9.8 Newton force, wind force. Okay, same as engine force too. Okay, so that's our thought experiment where we can disprove Mr. Einsteinian axiomatic proposition, the principle of equivalence, something like that, equivalence. Okay, okay, we'll take 5 minutes break, okay, and then we'll take it easy, all right, and yeah. All right, let's take a break. All right. Okay, we are almost done with the general relativity disproof. Okay, so that's the initial setup, right? Yeah. If we're designing third experiment to disprove Mr. Einstein's general relativity, that's what we're doing. Okay, so uh, after we're done with this, we'll talk about whatever. Okay, so all in those different forces, uniform force field, be it gravitational, electric, magnetic, or wind force, or jet engine force, whatever it may be. Okay, or you can just rowing the boat. Okay, so now the force is constant, so there'll be acceleration, right? Yeah, in all those cases with all different forces, each respectively. Now, but let's say this object is being blocked, so there is force. So this object is feeling the push and pull, right? But it's being blocked by what? A scale, like weighing scale, to weigh how much this object weighs. That kind of scale. most likely spring based. Okay, so this case blocking the way when this where this object is wanting to accelerate into that kind of direction, the scale is blocking it. It's spring based. Okay, that's what this needle of your weighing scale, yeah, it's spring based, right? Yeah, how to measure how much this spring contracts, that's measure of force, your weight, right? Okay, so in all those scenarios, the scale will read 9.8 kilogram because that's by definition. You have 1 Newton, 9.8 meter per second squared acceleration, right? Then it's 1 kilogram. Okay? So all those forces are equivalent in terms of acceleration, in terms of this weight, this inertia by this mass. Okay, so there's nothing special about gravitational force. Okay? So Mr. Einstein tried to do this unified fields theory, right? But he failed, right? Because he got the wrong assumption. He thought gravitational force is special, but it's not. That's where he failed. Okay? Now, so they will have the same weight, same force, same whatever, same mass, okay, and same force, same acceleration, same everything, okay, all those different scenarios. Now, but if there is no scale blocking the way, these objects will start to accelerate 9.8 meter per second squared, right? And in all those scenarios, if there's this photon going across, kind of perpendicular to the direction of acceleration of these objects, okay? To these objects, the photon will look as if it's making this trajectory, parabolic trajectory, okay? Because that's the Newtonian classical mechanics, okay? Yeah. Is second order equation, okay? So, then, scenario number one, yeah, it's gravitational force. So photon to this object will look like it's bending, right? Okay. Second scenario, electric force field. It will look like photon is bending when this object is going forward, like constant acceleration. Okay. Magnetic force, wind force, engine force, all the same. Okay. Yeah. Photon will look like it's going down like this kind of trajectory. Okay. Parabolic curve. Okay. Now, next question. Does that mean photon would bend due to gravitation? If it does so, it should also bend in the electric force field and magnetic field and also wind force field and so on. Now it does not make any sense. Why? If we follow along the line of logic that Mr. Einstein did, because electromagnetic field, photon is electrically neutral and magnetically neutral, and it has no mass, no volume, photon. So just like it's not going to bend in electric field or magnetic field or wind field, it will not bend in gravitational field either, because it has no mass, it has no magnetic pole, it does not have any electric charge, it does not have any volume. So that's what this proof, QED. Okay. It will be short ends with this proof. Yeah, it's more conceptual proof. It's not like mathematical proof. physical proof, but it's more conceptual level proof, but still. Okay. To me, that's proof enough. Okay, so whether it's enough or not to other people, it's up to them. I'm going to just present this proof, and whether people accept it or not, it's up to them. It's their freedom, their right. So after that, I'm done. Okay, yeah. With this paper. Yeah. Yeah, I'm just chilling. It's been very busy and long day, so I'm also trying to digest myself as well, digest too, because day like this, I eat dinner at work, and I ate quite a bit, so I'm full. So we'll take another 5 minutes break. Okay, now house is getting hot. I turned the heater and I don't need this jacket anymore. I don't think. Okay. Let me grab a beer. So let's think about why so many people were wrong, just like Einstein's wrong. So I mean, it's not It's not like Mr. Einstein intentionally misled people. No, he didn't know. Okay. Okay. So how about other people? Why did nobody able to point this out? Part of the reason is that political turmoil during World War II. So Mr. Einstein, the Prince of Peace, just like he was like Jesus, savior. Okay, so the symbol of peace, right? Uh, so yeah, they wanted to sympathize with him and support him. He was international star, symbol of peace during the World War II. All the international scientists coming together when their country, their politicians are fighting each other. So it's very uniting figure Mr. Einstein was, right? So back in the days. But now that World War II is over, there's no need for sympathy or think about those geopolitical configuration of his time because World War II is over. Okay, so now we can do real science, not politics. Okay, so that's one reason that people sided with Mr. Einstein. Second reason is this: Mr. Einstein used tensor calculus, which is very difficult mathematics to understand. Okay, people were fascinated. I was fascinated. Yeah. So I did study some tensor calculus a little bit. All right. Just like many people, yeah, I wanted to understand general relativity theory. Okay. So that's kind of diversion, distraction tactic, like a magician, right? Yeah, sleight of hand, that kind of like fancy gesture, like yeah. So people were distracted by this very exotic branch of mathematics, tensor calculus, okay, that Mr. Einstein popularized, which is great contribution on his part. And because tensor calculus is very beautiful mathematics, okay, it's great. Uh, so yeah, people were just following along the Mr. Einstein's the tensor calculus and what the field equation, and they're just too busy following his line of logic. Okay, so they didn't quite have time to think it through. Okay, so and it's still going on today. They don't question Mr. Einstein. They just it's like groupthink, just like in politics, like Democratic Party, Republican Party, groupthink, right? They just want to agree, right? Yeah. So scientists, yeah, they're people too. Okay, they're no better than politicians. Get today, climate change, all that, right? COVID-19, they're all non-scientific line of reasoning there. Okay, so scientists are no better than politicians. Okay, so they're all the same. The people are people, you know. But there are a few of us who question the mainstream. We are minorities, right? Uh, we are the teenage ninja turtle, teenage mutant ninja turtles. Okay, the mutants, mutation, the minority. Yeah, we are the mutants that actually drive the evolution forward. Okay, mutants, just like in biology. Okay, maybe I should write that down. Okay. My cell phone is charging now. I grab it. I charge it later. This is too important. Okay. Yeah, I'm writing down a lot of notes for this general theory disproof part. Good. Let me. Now that I have my cell phone, let me show you my selfie that I took earlier in bathrooms. Hmm? Yeah. Let's do that. I kind of like the way it came out. Maybe not. Eh, that don't look very good. Oh, how about that? That's earlier today, okay? When I had more energy. Now, I got no energy, okay? So, bathroom selfie. Yeah, there's Hawaiian t-shirt underneath the dress t-shirt, right? Some funny photos. Making faces. Making faces again. Yeah. During my break time. Just me yesterday, and fallen leaves, tree leaves. Oh, nowadays it's beautiful. It's full color, you know. When the wind blows, the yellow leaves fall like rain. Oh, it was beautiful. Couple of days ago, in my front yard, it was pretty. Oh, it was beautiful. Yeah, autumn. Many people's favorite seasons. It's definitely my favorite season. I love spring too. I love winter as well. I don't like summer. Why? I don't like mosquitoes in the summer, and it's too hot. When I run, I sweat in the summer. Okay, it's like feels like sauna. When I run in some other seasons, I don't sweat because my body cools down of this cold temperature in Alaska. Okay, I don't sweat at all when I run in the winter. Not at all. Not at all. Okay. Yeah, but summer it's not easy to run. Okay, but I do run though. So I when I run, I get really sweaty. That's why I don't like summer. And also I don't like mosquitoes. Ew. So I don't like summer very much. But summer is many Alaskans' favorite season because they can go hunting, fishing, and weather is kind of nice. But it is. But I don't like summer. Yeah, I don't really fish or hunt per se. I go fishing sometimes, but I don't really do it often, and I don't have mosquitoes. And, yeah. How about cold weather? I don't mind. I like winter. How about the darkness? I don't mind that either. Dark when it's dark, it's very comfortable, and I can open my eyes bigger when it's darker, like an owl. Yeah, I like winter. I have no problem with coldness or darkness of Alaska winter at all. Okay, when it's dark, it's very comfortable, and I can open my eyes as big as I can, and it's so cool. Cold temperature, no problem, because I always exercise. I prefer cold temperature, okay, because unless it's like Fairbanks. I've been to Fairbanks once during the winter time. That was too cold. But out here in the down here in Valley, oh, it's not that cold. Okay, in Alaska, yeah, the valley is very nice. It doesn't get too cold. How cold does it get? Well, last winter it was like negative 20 Fahrenheit. That was about it. Okay, so global warming, I don't think there's, well, at least in Alaska, we don't have any problem. Ice melting, so what? How about polar bears? Ah, don't worry, okay? We can feed them, okay? Well, we can, if they're gonna starve to death, I mean, we can make a zoo out of and feed them and make some money off of the polar bear habitat. We can feed them, okay? We got money. If not, we'll make into a zoo, safari, so that people can bring food and to feed bears. Then we can feed bears for free, and also we can make money because yeah, travelers, tourists. Okay, no problem. Yeah, and to me, global warming, at least in Alaska, is a great blessing. Okay, because we have warmer winters. Without global warming, winter in Alaska is too cold. Okay, so I have no problem with global warming. Okay, so climate change, I welcome it. Actually, I want there to be global warming because I'm in Alaska. Okay, it's warmer here in the winter. I'm kind of being selfish, maybe. Okay, but so what? Alright, climate has always changed in the history of the Earth. Okay, so all this climate change, all they don't understand science. Okay, so even scientists who side with this majoritarian anti-climate changeism, uh, they don't know what they're talking about. Okay, so how about COVID-19? Yeah, we'll take 5 minutes break and we'll talk about that too. Okay, other scientists, don't listen to them. Okay, listen to me. I'm the best scientist. Okay, so don't listen to other scientists. Listen to me. Okay, and me only. Other scientists, they don't know what they're talking about. Okay, so. Yeah. Okay, we are back, ladies and gentlemen. Um, yeah. So the way Einstein did his general relativity theory, the way he started is okay. So yeah, it's like it's very, very. I mean, it's interesting way of thinking, but I think he erred. Okay, so yeah, just he had this thought experiment. Okay, this elevator in space. Okay, so what we did about 30 minutes ago so is that what he did is kind of vertical comparison between accelerating elevator and the gravitational planet. Okay, but what we did was horizontal comparison between two several different forces. So what Einstein did is kind of vertical comparison. What we did is horizontal comparison with all the different forces out there. Okay, he tried that in his unified theory, unified field theory. Okay, but he should have done so early on. That's where he erred. Okay, before going any further. Okay, well he did horizontal comparison, and we started out with horizontal. He did vertical comparison, but we start out as horizontal comparison, like he tried in the unified field theory after he finished this vertical dimension with all this tensor calculus and whatnot. Okay, so it's not necessary at all that we understand tensor calculus or his field equation, not at all, in order to disprove general relativity theory. It's not necessary at all to understand tensor calculus. I don't know any tensor calculus. I know just a little bit, okay, but not to the level of understanding his field equation. I don't. But it's okay. Why? Because his field equation is wrong. All right. How about special relativity? E equal mc squared. That's also wrong equation. Okay, but you cannot possibly existentially verify that correctness of the equation. Why? Because very small mass multiplied by c squared, not even c squared. It's a super duper big number. Okay, so the loss of mass delta m is equal to E over c squared. Okay, so like nuclear energy or nuclear power, big energy divided by a very big number, c squared. Okay, so huge margin of error there. Okay, so and the loss of mass is tiny. You cannot measure that outside of margin of error. That's simply impossible. Okay, so this equation equal mc squared is not falsifiable. Thus, it's not a science. It's a science fiction. I mean, yeah, his theory is very popular among science fiction writers because his theory is science fiction. Okay, that's same kind, pretty much. Mr. Einstein had vivid imagination, just like sci-fi writers. Okay, they're the same kind. Okay, but yeah, they are not exactly scientists, though, right? Well, Mr. Einstein, he did some photoelectric effect, Brownian motion. Yeah, that was good. Okay, but otherwise, he erred. Okay, and he did inspire many sci-fi writers and filmmakers, like Back to the Future and whatnot, right? Time Machine. He did contribute to humanity in general, outside of science too. Okay, he's contributed to establishment of straight brand new state of Israel, Zionism. He did play a big role there too. Okay, and also, yeah, Einstein's letter. Of course, he didn't write it. It was Dr. Szilard. I think it's Hungarian science physicist or something. Okay, he wrote it, and Einstein signed it and pretended Einstein wrote it. Okay, so yeah, the development of nuclear energy, nuclear bomb, the end of World War II, Mr. Einstein did play a role, and also development of nuclear energy too. Not his equation though, but his letter to FDR, the Franklin Delano Roosevelt. He didn't write it. It was Dr. Dillard, but he signed it. Okay, Einstein's letter. Okay, maybe I mentioned that too. Okay, he did contribute to humanity in many ways. Okay, but still, his special and general relativity theories were wrong. Okay, they are wrong. So, um, yeah, but he made contribution. So yeah, the Dr. Zillard's letter, Dr. Zillard Einstein letter, yeah, that's what spurred this Manhattan Project that President FDR approved. Okay, so there came the atomic bomb and also nuclear bomb and also nuclear energy. Okay, so Mr. Einstein he signed that letter, so he did play a role. Okay, but his science, special relativity E equal mc squared, that did not play any single role in the development of nuclear bomb or nuclear energy. Okay, so well, first of all, it's a wrong equation. Okay, so yeah, all this nuclear bomb, nuclear physics or whatever this particle physics, it has absolutely nothing to do with special relativity. Okay, because special relativity is a wrong theory, right? So nuclear energy is about this chain reaction, exponential chain reaction of nuclear fission, right? And it has nothing to do with special relativity whatsoever. Okay. So E equal mc squared. That equation was not necessary for the development of nuclear bomb or nuclear reactor, nuclear energy. No, it did not play a single role. Okay, because well, first of all, it's a wrong equation, and nuclear physics was not developed from special relativity theory. No, it's particle physics. It's a nuclear fission, nuclear fusion. Yeah, it is particle physics. It's not special relativity whatsoever. Okay, so it's not based on special relativity. There's a common misconception. It's a myth. Okay, people don't know this because they didn't study physics very much. Okay, but some of us do know. Okay, who seriously studied physics somewhat. I didn't study too much physics, but I know enough. Okay, what else? So yeah, I mean, I don't always look good, but I try to look good. Okay, so when you it's about facial expression. Okay, and also be happy and make your facial expression bright. I learned this from some Korean actor. Okay, and also from my parents too. Okay, how to manage your facial expression. Okay, yeah, be happy. Okay, yeah, smile and be happy. Have a bright face. Don't be like, oh no. And also be happy. Can you be happy? Work and work out and study. Right? Have a good hobby. It's not necessarily you are career oriented person, okay? So even if you are not career oriented person like I am, uh, you can still be happy. You can pursue your family, your hobby, whatever, right? But it has to be legal and also moral, ethical. Hmm? Yeah, and also exercise, diet, right? I don't have potbelly, okay? It's just this clothing. Yeah, I suck it in. If I don't, yeah, it does bulge out because large intestine, lower intestine, how long are there? Are they? They're very long, like, I don't know, 20 feet long, 30 feet? Intestine, large and small intestine, okay? They're long. They're all folded down here. So, due to gravitation, if I don't suck it in, yeah, they bulge out, of course. So what? So I just keep sucking it in. Yeah. Okay, let's take 5 minutes. Let's stop and restart. Okay, so we'll take like 5 to 10 minutes break. Okay, so okay.